Okay, what fun. Thinktech Talks here, the SOEST hour on Mondays from 1 to 2. And today we're going to talk about the data center at Manoa, the big data. Big data at Manoa is getting still yet bigger. That's a long title, but there you have it. We had to negotiate that. Okay, and running from the table all the way over at my left is Stephen Smith. He's the director of the, he's the interim vice president for information technology, and the CIO.
That's right.
Of the University of Hawaii.
Mm-hmm.
And he has, at least part of that is what David Lasner used to do.
All of that is what David used to do.
Okay, all right, so that's important. And next to him is Kevin Hamilton. He is with SOEST. He's the only legitimate SOEST person we have at the table. Mm-hmm. And he is the director of the International Pacific Research Center. I get that right? Okay. And David Chin, he's the chair of the department, the ICS department, and ICS standing for?
Information and Computer Sciences.
Okay, Computer Science Department.
Right.
This is the most important department in the whole place, right?
I think so.
Well, you know, people think they equate information science, computer science with, the whole enchilada. What they don't realize is that computer science is everywhere now.
Oh, yeah.
There's no department in the university, no school, no college, no nothing that doesn't have its own skilled information technology people. Well, probably all came from you in one way or another. I hope you let them in the door when they want retraining.
Oh, yeah. We welcome everybody.
Yeah. Anyway, so the news story, and we'll start with Stephen Smith about this. The news story is that the building, which is housing big data at the campus, which has been, some people call it the David Lasner building. I don't know if that's appropriate. Mm-hmm. Lasner Hall. No. Yeah. Is just now coming online. Yeah. This is a major thing, been underway a long time. Tell us about it, Stephen.
Yeah, you're right. This building has been a long time coming, literally years and years. David Lasner has been the primary person working on this, but his predecessor also worked on it, and his predecessor's predecessor worked on it. So this is a brand new IT center, 72,000 square feet, brings together all of the IT services. IT services serves the entire system, all 10 campuses, and is the central IT provider for the Manoa campus, and brings everybody together for the first time. 7 different buildings we were spread apart, and so that consolidates us all, makes working just the proximity a lot easier. Included in this building is an 8,000 square foot data center, and I think that's what we'll be talking a lot about with big data and what we can do. But it also has 2 state-of-the-art video conference rooms.
What is state-of-the-art? That sounds like video conferencing to me.
Yeah, state-of-the-art means that it has 4K video conferencing capability. That's super high definition. That becomes important when you're doing certain things in research, but also when you really want to have just a real interactive video conference. The greater the resolution, the more it feels like we're just sitting here across the table.
True. You think quicker, you respond quicker.
That's right.
The whole conversation is better.
Yeah.
But let me ask you, just as a footnote to that, and I recall that the university has super duper high speed broadband.
We do.
It's a whole new network, and it's much faster than what you could get in the economy.
It is.
And that connects, of course, with your computer center.
It does, and in fact, the head end for the University Computer Network resides here in the IT Computer Center, so that we have the fastest access for our students, our faculty, our researchers, and our administrators as well.
Time for me to go back to school again.
Yeah.
So how fast is fastest?
Well, we have 10 gigabit connections, multiple ones that connect us to the mainland. We have then 10 gigabit connections that connect all 10 campuses in the system. And we are just in the process of connecting up 10 gigabit connections around the Manoa campus to all the various research capabilities like SOEST. So the researchers there will be able to get the fastest access when they want to share their data, when they want to analyze their data, when they need to do work with their data.
Just a comparison, you know, we broadcast here from the studio. In fact, we're broadcasting right now onto the internet at 100 megabits.
100 megabits.
This would be 20, wait, 20?
No, that's, let's see.
20,
100 mega, I'm doing the math real quick in my head,
200.
but it's about, it's
200
more,
times
no,
faster.
it's more than that. It's about 1,000 times more than that.
1,000 times faster.
Yeah.
God.
But you need that when you do big data. And you need that when you're going to do things like visualization, when you're going to do things where you're going to take very large data sets and put them together and run some computation on some of those when you're running the cycles. So that all happens right there at the IT center. We also have a digital content media content center for faculty to come to create digital content for classes, presentations, whatever they need to do.
PowerPoint, that kind of thing.
All of fancier than that, but certainly PowerPoint, but other kinds of things that they want to do with digital content. We have a training lab. We have the help desk is located there. People call, they walk in, or they send things by email or requests there. And then on the third floor of the IT center, we have the emergency situation room. That is where the university...
So military.
Well, it is in some ways. That's the place where when we have the hurricane, that the disaster folks are going to assemble. It's got redundant power. It's Category 3 hurricane resistant. That's the first 3 floors in the building are. The data center is on the 2nd floor, and intentionally so that if we ever had flooding, the data center is not going to get hit with that. We have redundant power for the data center as well as for this emergency situation room. We have 3 generators provide backup power and battery backup. So if there's a power outage, the batteries backup snaps in immediately.
This is eons beyond anything you've had before.
It's quite a leap for what we've had before, and it helps consolidate the university IT resources, the administrative, the instructional, but really the research. And I think one of the places that we're really excited, we are making available what we call virtual hosting for any university department, any university campus.
Anywhere, anywhere.
Well, within UH.
Within UH,
Yeah,
okay.
within UH. Can come in and locate their hardware in the data center. There it's secure, environmentally controlled. It also helps reduce the energy footprint for the university as you put things into one data center. We also provide what we call co-location. So particularly for researchers, they may have very specialized equipment that they need to take care of, but they can locate it, co-locate it in our data center so they don't have to maintain the air conditioning and the physical security and all of those other things that go along with housing hardware. But I think then one of the most exciting things we're doing is we are just, I mean, literally on the edge of putting on the street a request for proposals for what we call an HPC cluster. HPC is high performance computing cluster, and that's specifically aimed to meet the needs of our researchers who need that kind of compute power. And I'd turn that over to...
Before we leave that, though, that's HPC is like what was going on, or what may still be going on Maui with the High Performance Computer Center.
Yeah, things are still going on Maui, but this is similar functionality. And this is the direction that things are going. You know, Moore's Law is still fully in effect for computing, where every 18 months things essentially double. So the power expands, the footprint that it requires gets smaller, and you can do more with less in terms of this.
Okay, and I do want to go down the road here, but before we do, I'd like to, make a comment first. that this is something the state can learn a lot from, because the state has been, with Sunny Bagwalia,
Yep.
and so far it hasn't really had that much traction. They should all come and take a look at your computer center and learn.
Well, it's interesting you bring that up. As a matter of fact, we have continue to have conversations with the state and with various departments within the state, and talk with them about working collaboratively to do some of this co-location I spoke of.
Yeah, that's great. Well, that's Tom Apple's initiative of, integrating with the community, helping the community, stepping down into downtown once in a while. So I just, this sounds to me, for an information technology person, Stephen, this is like the ultimate toy store. It doesn't get any better than this. And I wanted to just, you should explain to the people how your life took you to this exquisite position where you run and you have created and you run this fantastic computer center.
Well, I'll tell you what the secret is. I let David Lasner do all the hard work, and then he stepped in as interim president, and it's a shame. He really did, and he deserves the lion's share of the credit for getting this building in place, and for what it does, what it's going to do for the university, but he's never been able to actually occupy it. And so he walks by and every once in a while will look into the office I occupy, which should be his office there, would have been his office. So that's the secret I had. I was fortunate. I came on as the deputy CIO here about 3 years ago from the University of Alaska system. That actually, surprisingly, in Alaska and Hawaii, we have a lot in common between the two places. And so one of the reasons that I came here and was attracted here, besides being a graduate of UH a number of years ago and wanting to come back home again, is it's very rare these days in IT land that you get to work with a completely brand new building like this. Data center space is very expensive, and by the way, this building came in on budget.
Which was?
$41.7 million.
I would have guessed more. Good for you.
And so it came in on budget, and it is state of the art. We do some things with cooling, for instance, in the data center that reduces the normal energy you have to have. When you go into most data centers, it feels like you're in a meat locker refrigeration system. It's actually not that bad in the data center, and it's because of the way that we cool it. We have smokestacks on top of the racks that take the warm air out. We also water cool them on the rear with water cooled. It's like a refrigeration device that keeps them cool. So we have great expectations, great hopes that we're going to help the university save on energy dollars as we begin to consolidate hardware into this new data center.
Very exciting. So let's talk about what this means to you, Kevin.
Okay, so I lead a center of climate modelers. So we're running very large simulation models of the ocean, the atmosphere, coupled ocean atmosphere systems.
Large, tell them what large is.
Large, well...
In gigabits and Google bits, whatever.
Well, we have a regional model for climate projections in Hawaii that we actually talked about 2 months ago on the show. And when we run this in our current in a reasonably high resolution, so we resolve the topography over the Hawaiian Islands, we need about 80,000 processor hours to run 1 year of that model. So if we had 80,000 processors all working together, it would take 1 hour, or one processor, 80,000 hours. So we have a very strong need for parallel computing, for high performance computing. We have many processors acting at the same time to share.
How many days is 1,000 hours?
Pardon?
How many days is 1,000 hours?
500 hours is about a month.
Oh,
yeah.
okay. So this really speeds the work up for you. This changes everything.
Yes, so parallel computing is absolutely necessary. High performance computing is absolutely necessary for the kind of work we do.
Yeah.
And we have, we're in some ways we're leaders here in some aspects. So we've been scrambling like crazy to get various types of computer resources. So we have our own small clusters, which are sitting in our own air-conditioned rooms, and which we look forward to perhaps moving to the new building. We use the Maui supercomputer when that was easily usable for several years. And then on sort of a different scale, we're partners with Japan, so we use very large supercomputers, the kind you couldn't imagine in Hawaii there. So the so-called Earth Simulator was built at a $500 million investment in 2002. So, but we have a very strong need for as much local computing power as we can get. So we're extremely excited about this RFP going out for a new cluster. And the initial investment is of the order of, you're the expert in the money, but something like $1.5 million.
How much?
$1.5 million. But I think we should think of this as maybe a starter system, and the individual investigators should be out looking for chances to get, federal agency money, for example, to expand this. And the fact that it's in a what will be an absolute world-class facility in terms of the environment, the processors will sit is a huge improvement. Now, as I say, we have our own machine room with our own problems with air conditioning, power outages, and so on. So I think David Lasner's done a fantastic service to everybody who needs reliable, high performance.
Takes us to a new level.
Yes,
Yeah.
yes.
So I hope you and Stephen should stay friendly. You should.
Oh, yeah.
Yes, I
Yep,
think we'll be
we
very
are.
good friends. So Steve is actually employing one of my people half-time for the last few months, helping them actually formulate the RFP, because we do have experience in my center in building our own clusters.
I want to put that in perspective, because the show we did with you was one of a number of shows with SOEST, and every show we've done with SOEST, really, in my recollection, is it involves big data. Somebody is always making big data, getting big data and processing and analyzing big data. For example, in the case of weather, for any significant part of the Earth, you take all the information about weather, all the known information from satellites and otherwise, and you put them in fields in a database. You can imagine how many fields there are. I can imagine. There's lots of fields.
Right. But from a modeling point of view, it's even worse, because we're projecting into the future, say decades. So we're generating many snapshots of the whole structure of the atmosphere. And so we generate enormous amounts of data.
So the number of data fields huge, the number of records huge.
Yes.
And then when you start processing it, it gets much huger, and you can't do this on a MacBook Pro,
No, definitely.
even if you really wanted to. So, and you're not the only one. I mean, there are others in SOEST I know who deal with the same volume of data, and all over the university, it's like that. So this is, it seems to me this is like critical to the university going forward. It's a new chapter for everyone. SOEST is important because SOEST is heavily involved in data from what you do, but it's other parts of the university as well.
Oh, yeah. Another big data producer and user is the Institute for Astronomy.
Yeah. Right.
And with the telescope systems, that generates huge amounts of data.
Yeah.
Yeah. So it's across the university, and you're right. Where everything is going this day and age in research, it's big data. And how do you manage that? How do you store it? How do you handle it? How do you process it? How do you make sense of it? Yeah. Yeah.
Well, somewhere along the line, we should talk about backup for all this. Because I know that if Kevin loses his data, he's going to be very unhappy.
He will be very unhappy.
Like a life force.
Yeah.
I'm going to take a short break now that it's 1:20, and then we'll come back in a minute. We have here Stephen Smith, Kevin Hamilton, and David Chen. We're on the SOEST Hour here on Thinktech Talks. We're talking about big data at Manoa is yet still bigger. That's a negotiated title. We'll be right back after this short break. I'm Jay Fidell. That's Sharon Moriwaki of the Hawaii Energy Policy Forum. And every Wednesday we have Hawaii, the State of Clean Energy. We've been doing it for some time now, and we have some fantastic guests on there, unbelievable guests who give us insight into what is going on in a very complex, sometimes very confusing, sometimes very disappointing area of progress in the state. So we love doing this. We love meeting them. We love talking to them. We love having their ideas out on the table. So maybe, just maybe, we can all make some sense of what's going on. Sharon, what do you think?
I think that's absolutely correct. We enjoy ourselves meeting with all these people and hearing about the energy and the state of clean energy, and hopefully we advance clean energy for the state. So it's terrific. Join us. Come
Okay,
join
it's
us.
every Wednesday. Okay, Wednesday is Energy Day. Every
Energy
Wednesday,
Wednesday.
4 to 5 p.m. Hawaii, the State of Clean Energy, here on Thinktech Hawaii.
Energy
We'll see you
Wednesday.
there. Okay, we're back. We're live. We're here at Thinktech Talks, the SOEST Hour, talking about big data at Manoa. Big data at Manoa is yet still bigger, with Kevin Hamilton, Stephen Smith, and David Chin. And I'd like to just point back over there that behind us on our green screen is the new computer center. What is it?
That's right.
I mean, I know we have a picture, and that's good, but what can you give us a handle on what it looks like? How does it feel to be in there? Do I have to present a security badge and all this?
As a matter of fact, we do have security, and we have a desk at the reception desk when you come in on the first floor, right in front of a big video wall that we have there, and everybody that's a guest comes in and signs in, and we do have security there. You can't even get to the second floor unless you've been approved and you're escorted there, and we do that simply for security reasons. So it is a very secure building.
We have to check back with you guys from time to time, because that's the way the public can appreciate it, even if they can't get in.
Yeah. We're happy to give tours. We give tours all the time. And if folks do want to get a tour, just get a hold of me and we'll set you up so you can go and visit the building. It's 6 floors, all IT, and the first floor is for public meeting space and video conferences and training and help desk. Second floor is all data center. Third floor is where we have our emergency situation room, and then staff are on the other floors.
So David Chin, the chair of the computer science department in the university, that's another great job. You know,
Oh, yeah.
I'd like to have any one of your jobs. Maybe my next life. You know. So what does this mean to you? I mean, computer science, this big computer center. My goodness, there must be a strong nexus here.
Yeah, well, first of all, I'm a little peeved and jealous because we were originally scheduled to have a floor in that building, but when they ran short of funds, we're the first thing got kicked out.
Well, they probably built it so you could add a floor on the top. You know.
That would be nice, but no, it's a really nice building. I've gotten tours 3 times already, and we're really excited because one of our initiatives, along with ITS, is this new cyber range, which is basically a computing cluster that we're using for both students and for the public in Hawaii. And in fact, this July, the National Guard will be holding an exercise with the cyber range. Basically, the cyber range is designed to train people in cyber defense, right? So when hackers are trying to break into banking systems or TV networks, so for example, in South Korea or North Korea, took down, I think, 2 banks and 3 TV stations for a few days, just by attacking them, right? Potentially, the same thing could happen here in Hawaii. Who knows what the North Koreans are going to do, right? So the National Guard trains for that eventuality, and also we're training our students to get jobs helping to protect, like the Bank of Hawaii, from getting hacked and your money stolen, right? So this new cyber range is fairly compute intensive, because we need to simulate large systems like banking systems and so forth. And the problem is we'd like to store it in our building, which is Post, same building as my friend here, but there's not enough AC, and potentially we have to put in more power. And so the great thing is we can put it in this new IT center on the second floor and have them take care of everything.
So that leaves an interesting question, because in your case, Kevin, and in your case, David, you have had your own facility, for better or worse. Maybe it didn't work, as largely as you wanted it to, but you had it. Now you're moving over to Stevens Computer Center, which is enormous and magnificent. What part do you keep of your, of your computer facility? What part, now that you turned it over to him, what part do you keep?
Well, we still have to maintain it, so they don't have the people to actually run the system. They take care of where it's housed.
It's a co-location kind of
Right,
thing.
exactly.
So you can control it from your machines.
Yes,
It's just that they're doing the server, so to speak.
right,
About what you had a server in-house before, now your servers are with them.
exactly.
Are you comfortable with that? Are you worried about that?
No, perfectly comfortable. They
You
have,
look comfortable.
yeah, they have better security than we do.
They have redundancy? Do they have backup? Are they backing up in Indonesia or what?
We're doing backup right now locally, that is within the data center, so we've got redundancy. We also have an arrangement for an off-site backup that we're working on, and that's with DR Fortress. And so,
You mean the one with the big concrete walls at
With the
the airport?
yeah, that's right, yeah. So that we can also do off-site backup. And so backup and redundancy is one of our major concerns for research, for administrative systems, for all the records that we're maintaining as students and employees. We want to make sure that they're backed up, that there's redundancy.
It's not just research, it's everything.
Everything, yeah.
Whole university lives in your building. How do you sleep at night?
Well, I don't know if I should be saying this, that everything does come through there, but that's where we set up redundancy and to make sure that we've got things backed up. So if we had any critical failure, we could recover from that. And of course, then we prioritize the recovery. These things are essential, like a simple thing, but a critical thing, making payroll every 2 weeks, and make sure that those kinds of things move forward. But then preserving this data that Kevin and his folks all gather, because that's irreplaceable if something were to happen with that.
Lifetime of work. So, but how do you use the skills of ICS and David Chin and his students and faculty? In other words, do they come over and program for you? A center like this requires not only a lot of configuration for the hardware and all that, and sophisticated wiring and connectivity, but it also requires programming, interface. So you guys working together on that? How does that work?
We do work together on it in several ways. So we have a core of folks, developers, programmers, and database administrators and system administrators. They largely, though, make sure the infrastructure is working and where we have specific applications for the system, the university's financial system, for example, largely the administrative systems, to work on those. When we get into the special areas with research, the expertise resides over in those areas, and we rely heavily on their expertise. And again, we'll provide kind of the framework, the infrastructure. They provide the expertise for the actual application, for doing things. Same thing with David's department. The expertise really resides there. And then wherever we can work jointly with students, either at the undergraduate or graduate level, that's where the real talent and the future lies. Jointly, ICS, David's department, and ITS, my area, jointly hosted recently what we call a hackathon. Hackathon not in the negative sense of somebody trying to break into a system, but hackathon in the traditional sense of that term, to build a program. AT&T sponsored it. We held it in the IT center, and we invited any students in the UH who were interested to come in over spring break for 2.5 days and build from scratch in teams a mobile application. And so those kinds of things, then we'll find some sharp students there that either we may employ or will go out into the workforce and add their expertise to Hawaii.
Well, so this must be a luscious opportunity for you because you write software, increasingly software is enterprise level and it's big and it handles big data, it's got to be foolproof and all that.
Right.
So now, for the first time, you have this huge facility to play with, and not only for the cyber range possibilities, but for other things. What other projects does this open you to? Does this allow you to proceed on? And it's not only in terms of training, but in terms of actually creating software that will be usable in the university or elsewhere.
Yes, so ICS has recently done a big push into big data and helping people like Kevin handle their big data needs and their analysis. So we just hired one new professor who's an expert in parallel algorithms, and in particular in GPU, graphic processing unit algorithms, which is using the video cards that display the nice computer graphics and video games.
Kevin can use that.
Oh yeah.
Right? You can use that for weather and so forth.
In principle, but we need the expertise of the computer science.
Right. Wait,
Right.
if you don't want to have two expertises because it would take too much time. You got to focus on your science, right?
Yes.
So yeah, we've hired a new person in that area, and we've also hired an expert. In fact, we stole the premier expert in the world from the University of Illinois at Chicago, his visualization lab, who's the director there. We stole him for our department, and he's an expert in 3D visualization, and he's the inventor of the Cave 2 system, where you actually go into this sort of surrounding cave where you can look all around and see the visualization in 3D. And it's all done with not projectors, but with LCD panels. And they're specially configured so you can do the 3D.
Well, I've seen some of that, probably not as sophisticated as what you're working on, but it suggests to me that there's a commercial possibility for you.
Oh yeah.
In terms of protecting the information, rather the programming, the IP, and maybe even in marketing it. Maybe even. Are you doing anything like that, or do you see anything like that coming down the road?
That's probably in the future. Right now, we're concentrating on helping people like Kevin, process their data and visualize it, and do the science that Manoa is supposed to be doing.
So as his science, Kevin's science advances down the road, and as computer science advances down the road, you probably have changes in new frontiers, new edges to work on every day.
Oh yeah.
And how do you keep up with that? It must be hard because you're talking about a global change with thousands of universities and millions of students and faculty trying to make it better every day. How do you keep up with that?
It's not easy. You sort of have to specialize in one area and keep at the forefront of that. And even that's difficult. Right?
So are you saying then that looks like you're headed toward virtual what was the term you used a minute ago? It's the graphic representation of the data. Is that true?
Yeah.
Is that turning out to be the school's specialty?
It's one of the specialties that we're concentrating on. So just big data in particular. We're also concentrating on human-computer interaction. So how do you build programs that take into account the people who are actually using them and what they need it for. Right? So one of the big problems with large computer systems is that the programmers don't really talk to the end users and they really think like them, and therefore the systems that they produce aren't really usable, right? And we get a lot of that even at UH. We buy these financial systems or whatever that they're built from specs, right? And the people writing the programs never talk or very rarely talk to the financial people who are actually using them. And we end up with these horrible interfaces that nobody wants to use. Right?
Well, you can go on any bank. And I'm not limiting my comment to Hawaii Bank. Any bank can find the same thing.
Right.
So, it'd be good for you to develop some of those front ends. You probably can make some money that way. I see there's a real possibility, as opposed to, say, in SOEST, in weather, I'm not sure how much, technology transfer you can do. Because you're talking to the scientific community, maybe you're talking to the government agencies that do weather, but you, David, you can talk to the public, the business community. You can make programs for them and actually protect the programs, sell the programs, service the programs. I mean, there's money there, isn't there?
Yeah, but that's not really the purpose of the department. We're really here to teach our students and train them to go out and do that correctly, hopefully.
So where do they go? Do they stay here in Hawaii, or do they take a short plane ride to Silicon Valley?
Yeah, unfortunately, a lot of them go off to Silicon Valley and places like that. Washington State is very popular with our students, simply because that's where the opportunity is. And that always gets my goat, because I want more than to stay in Hawaii and build up our intellectual capacity here in our industry here, so that future generations don't have to go off to Silicon Valley to get the opportunities.
So for the teaching, permit me a question or two more. I'm very interested. I always wanted to be a computer programmer. I went into the law instead. But the big data things that you're doing with Kevin and other parts of the university and taking advantage of the center are not necessarily the teaching things. The teaching things, you bring the students in a lab, so to speak. Each one has its own machine, and you show them how to program. You show them the current languages.
The visualization is part of teaching. So when Jason Lee, who's our expert that we stole from University of Illinois, what he does is he has his students go off to labs like Kevin's, and spend a few months there learning what the data scientists do with your data, and what they need to visualize, and then it comes back and writes the code to actually do that visualization, and then there's always this back and forth, and then from what Jason says is when the scientists actually get to visualize their data, they make all sorts of realizations. For example, that this really shouldn't be like this, according to the theory, and therefore maybe their theory needs tweaking, right? Or maybe they have a problem in their data collection. So, just by being able to see this data as opposed to looking at numbers on the screen, it makes a huge difference as to what they can do with the data.
Sure, it's a sausage thing, because when you find out that something needs to be tweaked, then you may want to go back and rerun the whole cycle again, all those hours of computer time, to see if it works differently and learn something.
Yes. So I mean, if you look, not just what we do, but the whole international climate modeling community, we're continually rerunning, say, the 21st century, our best projections, improving the models, and improving the initial conditions and so on. So it's a continuous process of improvement. And from our point of view, the more computer power we have, the more we can accomplish. I mean, it's really that simple.
Yeah. Let's take a short break, and we'll come right back, and we'll talk about where this fits in the larger picture going forward for the university, for the community. We have here Stephen Smith, and we have Kevin Hamilton, we have David Chin, all doing computers heavily in one way or another, some more direct than others. This is Thinktech Talks on the SOEST Hour, talking about big data at Manoa and the fact that it is yet still bigger now today. We'll be right back after the short break.
I'm Hong Jiang, host for Asia in Review on Tuesdays.
And I'm David Day, host for Asian Review on Thursdays. Both of us broadcast our respective shows at 4 p.m.
And my topics tend to deal with questions related to environment, culture, history, and sometimes human rights.
And my shows tend to be on international business, foreign policy, geopolitics, and national security. And you can watch our shows live on the Thinktech website at thinktechhawaii.com.
And you can also watch us on YouTube or Olalo.
So come join us on Thursdays at 4 p.m. I'm David Day.
And on Tuesdays at 4 p.m., I'm Hong Jiang.
Aloha.
Aloha.
Okay, we're back. We're live. We're here on Thinktech Talks, the SOEST Hour, Monday 1 to 2. We're talking about big data at Manoa and the fact that it is yet still bigger than it was last time you looked. With Kevin Hamilton from SOEST. He's the director of the International Pacific Research Center, dealing largely in weather. We have Stephen Smith. He's the interim vice president for IT at UH Manoa and the CIO of UH Manoa. We have David Chin. He's the chair of the Department of ICS, which is
Information
Computer Science. Yeah. Okay, so this is our last opportunity to engage on the subject here today anyway. And I wanted to sort of take it, what we've talked about, and move it forward somehow. We are at a point, in the timeline, which is notable. We've come a long way to create the center. We have the center. You're making the center available. These guys are having new experiences with the center, advancing their science. Wonderful. It raises all boats, doesn't it? So the question is, now that we arrived at this dot on the timeline, what's the next one? Where are we going?
I think there's three critical things that this does. One is it sets up an infrastructure to make the university more competitive in terms of research. We can up our research game with this. By having this infrastructure in place, when Kevin or David or any of their colleagues go out for a competitive grant for research funds from the federal government, from foundations, from other sources, they can say, here's what we have right now. Here's where we can compete. We can then compete with the other research universities, the other research labs around the nation. And it's a very competitive environment.
Do they have facilities like you do?
Right now, we've got the newest.
Happy to hear that.
IT centers are kind of like roller coasters and amusement parks. Somebody builds a new one and they say, we got one that's 1 foot higher than everybody else and 1 mile faster. Somebody else will come out with something pretty good, but we're right up there. We're A1 class, so it makes us better able to do what we're doing and more competitive with that. Secondly, it ups what we can provide for our students and the experiences that they can have. And so when they get out of here, they're going to have a much higher quality in terms of what they've done, whether it's at the undergraduate or particularly at the graduate level in research.
Because they worked at the top.
They've worked at the top and they've been able to do things so we can give them a much richer experience, and it just improves the overall quality of the instruction and the research. And then third, it makes us much more efficient in the university, so that as we can do this, as we can take the systems that David and his faculty, we can take the systems that Kevin and his researchers may have, and we can house them there. We can provide the necessary network connections there. They don't have to think about that. They can then concentrate on the specific big data research, on the specific instruction that they're going to provide students.
That's where it's going, isn't it? The bigger resource you offer them, the less they have to be down in the weeds on doing computer things, having computer facilities redundant, with yours. So that means they can approach their science in more of the time, and then they can have the advantage of more time for more pure science.
Yep.
And this changes the formula around
does.
the university.
Yeah.
Yeah.
So it's a game changer.
A game changer. So how do you feel about this, Kevin? How's it going to change the game for you, for SOEST, for weather modeling?
I would say certainly for the climate modelers and for some of the solid Earth modelers, put solid in quotation marks since they're looking at the flow and deformation of the Earth over time. It could be a very important.
It seems to me that it's even more important because of climate change, because we need what you're doing more every day.
Yes, so that's what we hope for. We're trying to provide the best possible information to guide climate change. Our center has a mission in the Asia-Pacific region, but in particular we're leading for Pacific Island climate change projections. And as Stephen said, you have to think of this as a competition. We're doing good stuff, but everyone else in the world is trying to compete for the same research support. And to the extent we have world-class facilities, it gives us a huge advantage in going out and trying to solicit the basic support, and to attract the top people as well, top students. And I can take students and coming wanting to do PhD meteorology and say, look at that building over there. It's just beautiful, and
Even on the back of the screen,
Yeah.
it's great to have this picture. One thing that strikes me is that as we go down the road into climate change, I'm talking from the point of view of the community who awaits your research. We want to know what's going to happen, what is happening, what's going to happen. It strikes me that if you have this facility available to you, A, you can come up with stuff a little quicker than before, and B, tell me if I'm right, you can have confidence that you will be more accurate than you were before. Is this right?
yes. So the more detail we put into the model, the more confidence we'll have in the projections. So again, more computational power, more ability to store the enormous data sets we produce will result in better science, better, more reliable results we can transfer to other people.
It was a good idea. They should make David Lasner the president.
There's an idea.
Just a thought. Okay, the other David now. From your point of view, how is this going to, change things? How is it a game changer for ICS?
Well, it gives our faculty who, so besides the new faculty in parallel algorithms, we also have a faculty whose expertise is in high-performance computing. And of course, I mentioned that we stole away the premier researcher in visualization. All of these people need the high-performance computing to actually test their theories and their techniques and their algorithms, and help people like Kevin with their data processing needs. So to really do that, you need to have that high-performance computing facility, which is going to be housed in the new building on your second floor.
And that's the way you do. You run bug finding programs, right? In every piece of software, there's going to be bugs, and you have to test for the bugs. And we have a big facility. You can do better on testing for all kinds of scenarios to find the bugs. Am I right?
Yeah, usually bug testing is not considered big data because
I'm a small data guy.
Right.
I really, I'm
so
just,
for that sort of thing, you really don't need the high-performance computer to do that.
do
Right?
that at home.
Potentially. Right.
Well, the thing that strikes me is that people don't know where the computer science has gone. They're kind of fooled by the iPad. They're fooled by personal computers. They have no idea what enterprise level big data computer programming is. It's really the industrial model, and 99.9% of us never get to see that, never get to imagine what it is. And if you're a university or a global multinational corporation, you really have to know. And I think going forward, it'll be much more important. Even though it's great to have an iPhone, does wonderful things. In fact, the Supreme Court is hearing some very interesting cases about iPhones lately. There's a lot of law being created about the iPhones because they've been so disruptive. But you know what? The enterprise things are more important to the race and the planet. And that's what you guys are working on. And the kids have to understand that's where it really is. It's nice to create a nice app and sell a lot of copies and make $1 a copy or whatever you make. But it's better to change the world.
Well, you can change the world with an app too.
I suppose so. It's a different kind of change, though.
Right.
You do app design over there at ICS?
Oh yeah, we do that.
Okay.
As well as the high
You
performance
cover all the
computing.
bases.
We do everything.
Okay, closing words. Let's go around. Start with you, Stephen.
Well, I appreciate the opportunity to kind of talk about the new center. We're so happy that to have that and to show it off. And again, if anybody out there watching is interested to see what kind of goes on behind the curtain and to see how this all works, give me a call and we'll set it up so you can come on a tour of the new IT center on the Manoa campus.
You might have some calls.
Good.
You know, if nobody else, then me. With my camera. Kevin?
Well, thanks for the chance to be on the show today. And as probably the biggest users of potential users of high-performance computing on campus, we're absolutely delighted with the developments. In fact, the building's been built. It's got such a fantastic facility. And now we actually have an RFP to fill it with a high-performance computing cluster, at least a starter system, as I call it. Is a really a great thing for us. And we look forward to using it and producing better and more reliable scientific results.
I didn't catch that until now. You are the biggest user. In terms of the size of your data, is that what it is?
Well, in terms of compute cycles, for sure.
Yeah.
And so when the University of Hawaii had sort of easy access to part of the Maui system, I think certainly SOEST was the biggest user, and probably my center was the biggest single user.
Send them a Christmas card every Christmas.
Yes.
Vice versa.
Yeah.
How about you, David? Are you going to send them a Christmas card too?
Oh yeah, definitely.
What do you close? What message would you like to leave with our listeners?
Well, thank you for inviting me on the show, first of all. And we're excited because our faculty need the High Performance Computing Center, not just for the high performance computer, which we can use, but also to house some of our other things like the cyber range and potentially other things in the future.
Well, you know what it is. You don't even know what you want to use this platform for until you get closer to it.
Oh yeah.
You use it a few times for things, and then you find out there's more things you can use it for, and before you know it, you need another one.
Oh yeah. Yeah.
Well, I wish you all well in this great venture. This sounds like a whole new chapter for the university, and I think it will serve everyone well, including the community around.
It will.
Thank you, gentlemen. That's Stephen Smith, Kevin Hamilton, David Chin. Thank you for being on Thinktech. The SOEST Hour. Big data at Manoa is yet still bigger.
Thanks.
You.
Thanks a lot.